Well, it looks like we've got a stream. Are we actually going to go live? I found out it's about 20 seconds. No idea why. Hello, stream. Wake up. Oh, something's happening. Oh, got adverts. All right. Don't know why Twitch puts adverts on this channel. They never pay me any money. Cheapskates. I'm glad I don't do this for financial reasons. Oh. We have a sound test. That's working nicely. Oh, today's subject. Yes, it's an all-day subject, really. I want to explore this one properly, and it could be an eye-opener if people want to watch this ever. Which, well, not my problem. So, where is... there we go. What makes a game? Is today's thing. Talk, maybe? I might even do some programming if you're really lucky. Well, actually, what makes a game is a very, very broad subject, and it's a bit, it's a misleading title for the day. But it is a full day's talk and an eye-opener for any game programmers out there. So if you are a game programmer and you are tuning into this, if you dip in and out of this video over a long period of time, you might actually learn something. Maybe not. Maybe not. Maybe you've already decided for yourself what a game is, because that's the whole point of this talk. Nobody, and I mean nobody on this planet today, can tell you what makes a game. Because nobody knows. That's better. Right. I think we'll change over to the capture card. Will that work? Might do. Can I access it? Can I get that to full screen? There's too many questions. File, edit, view. Toggle full screen. There we go. Oh, is that all it does? That's clever. No full... No, I don't get full screen. You get full screen, I don't. That's typical. Right, I wanted to go onto this computer today for a bit. Just give me a bit of relaxation from Windows. The glory of Windows. I'm still waking up at the moment, so don't worry. Let's find a game. Oh, I'll need a keyboard, won't I? Yeah, that's a keyboard. We've got a keyboard. Right. So for demonstration purposes today, we're going to load up a game. So add software, which I can't read. That's good. Can't even read the screen. We're making Amber Rogue, aren't we? So Rogue. The original dungeon crawl game. 197.4 kilobytes. Not megabytes, kilobytes. That's about 10 times. Well, actually, it's more than 10 times bigger than the original in 1985. Okay, let's apply that. You can play this online. So if you're on Windows, just play online. Just go to a browser and just type in Play Rogue or whatever. Official repository is 85.4 kilobytes. Now you're coming down to about times 10. Okay. There we go. That's that done. It's an original game, so here we go. Let's give ourselves some of this. About there. I'm looking on screen now. That doesn't seem large enough. This is a bit weird. One sec. Let me check my monitor. All right, let's type it in then. R-O-G-U-E. That's interesting. That's a bit better. Let's have a look at the pages. That's about right. I think I got it about right. Yeah. All right. What makes the game? Well, in front of you is a 1985 original game. Exactly as intended in 1985. The code for it has changed a little since then. So this isn't the 0.10 release. This is 1 point something. Either 1.1 or 1.2 or 1.3 type of thing. What we have to understand is what we see in front of us that makes this a game. Now, In 1985, the gaming industry was in its infancy, shall we say, by today's standards, definitely in its infancy. This game was never designed to run on a PC, personal computer. It was designed to run on a mainframe, and it was to test mainframes. It was a mainframe tester, which is why it's in ASCII and not graphics. There's no graphics, it's just ASCII characters, which are the American Standard Code of Information Interchange, or interface, or something. I can never remember what the last I is for. Well, that's a bit of the background to it. What made it a game? What made it stay around and still played today? In fact, there are still large communities surrounding the offspring of Rogue and the roguelike. The roguelike set of games, which is a genre, I suppose, a game type, people will now call it. This is the original, the one that made it all happen. Which is why I want to ask the question, what is a game in conjunction with this on screen? So a game is, in practice, something that you enjoy doing that is pointless. Like making videos on Twitch. That's a game. Well, by that definition anyway. Right. Let's be serious for a minute. No, let's not. We're talking about games. That's the whole point. Fun. At the end of most of my videos, I try and say, have fun. There's a reason for it. Because a lot of people don't have fun, especially in the jobs that they do and on an everyday basis. And that's why the need for games has arisen and become more of a social thing. I mean, before TVs, why were TVs so successful? Why is a TV now the most successful piece of electronics next to a fridge ever? Actually, more so than a fridge. I bet you have more TVs in your house than you have fridges. Yeah, I think that's a better way of looking at it. And both TVs or televisions and games have something in common. You can switch them on and waste time. Which I find interesting. There was in the 70s, there was quite a lot of anti-television going on. Kids watching TVs, kids emanating TVs, what they see on TV. The amount of time people watched TV and TV addiction. And the same, well, we're still going through that with games, I suppose. Game content. And the typical game content that we see in the AAA games is something like what I've got in front of me. This is by today's standards a AAA game. It involves combat, and it involves winning. A win condition. The most successful games of all time are based around that idea, but the winning condition is vague. It's turned into a success condition rather than a win condition. So that's become a bit various on its definition, I suppose. Can I move diagonally? Yes, I can. All right. I got this keyboard's dusty. Hasn't been used for a while. Wow. Should clean this off. So this is the game. We've got rooms, we've got corridors. As you can see, a door is a plus sign. And it's a dungeon crawl. You go around the dungeon. You try to get to level 26, which is denoted by... why is this mouse in the way? I don't know. Which is denoted by this level here. So it's level... That's your dungeon level. We're on 1. We're aiming to get to 26 and find the Staff of Rodney. But they call it Yend, or think about it. Gold is your score. Hit points is how many points of damage you can take till you die. It's current and max. Strength is it's how it affects combat damage and to hit in the original game anyway. This is strength out of the maximum strength that you can currently have. There isn't actually an error in the original game. Not an error. A weird mechanic in the original game revolving around strength, which I'm not going to tell you about. Play the game, find out. Arm is armor. The higher your armor rating, the better. I'm not sure how high it goes in this one. Experience is the level of your character, your @ symbol, and how many experience points you have. Yeah, so 0 experience. I'm level 1 with 0 experience points, because I just started the game, obviously. It's turn-based, so if I don't make a move, nothing happens at all in the game. The game is now currently in pause state, so it automatically pauses after you've taken a turn. And every turn that you take in this game matters, and that's interesting. If you press I, you get your inventory. And this is where I stopped yesterday in programming. Because if we have a look at... Oh, I can't now because I'm changed my screen up, haven't I? 3 lines of English completely stopped me in my tracks yesterday because it involves the word data. And all games have data. And you can see that kind of data in front of you now. Rations of food, ring mail, a mace, a short bow, arrows. This is all data. It can be classified as items within the game that the player can either find or use or whatever, interact with. So I can, for instance, place the mace as my primary in my hands, or I can place a short bow in my hands to use the short bow. If I use the short bow, I can fire, well, in this game, throw arrows. It's terminated. It's called because throw is also used for like rocks or darts or stuff like. You can find other things like that. So it's a multi-use function. functionality. So it's just throw. I don't know how many bows you can get. I think there is only the short bow in the game. There may be a crossbow if you're really lucky. It's a very simple game. It's always press space to continue type of thing. So there you go. Gather my thoughts back again. So as a computer programmer programming games, I'm going to use that phraseology because that's the accepted terminology. As a computer programmer or a game programmer, let's call it a game programmer. If you want to be a game programmer, you have to learn about data. So how is the data stored in this game, for instance? Well, the simple answer to that is, in programming terms, it's just stored in blocks of memory. The game has a block of memory of size X with all of the words and numbers in there. So 0 to 9 is one block of memory, and it just accesses those blocks of memory to make up these numbers. A lot of people mistake in programming, it's such a blurred line between the word variable and the word data. Is a variable data? No, a variable holds data. So you would load data into a variable so that you can use it and process it or take actions on it. The variable itself isn't data. The variable is just there as a handy, helpful tool to help the programmer make sense of what he or she is trying to do. Well, let's see if we can continue our game a little bit now. I love this game, sorry. Okay, let's have a look down here. Oh, okay. So this carries on, does it? All right. Oh, we've got a door. Now, this is one of the interesting mechanics of this game. You open a door, and you can see the whole room. Suddenly just flashes up in front of you, which is nice. Some rooms aren't lit, so you can't see them. The monsters are denoted by a letter, which has come out of a block of data. I think we looked at that yesterday with our monster generator. We programmed the monster generator yesterday as part of the stream, and we saw that these letters were just held as a block of data in a string, or a character string. A character string meaning ASCII code, because each character is a number in ASCII in a character string. So that's how it's held. They're all held as numbers. Computers only deal with numbers. Interesting. I wonder how many people know that. There are no letters. There are numbers only. The closest representation to the numbers that the computer uses is hexadecimal, which is base 16. You can use octal, which is base 8. That was used in the earlier days of computing. Not really referred to these days, and in fact I haven't seen octal used in let's just say a few years. I think that's fair. Oh, I've still got this one on full screen over here. I can't see what it's doing properly. So yeah, with MetaMonster, what happens? well, we go into combat, and to combat, we just bump into them. There we go. It's come towards us. We made a move. It made a move. So when we move, it will make a move. So if I now go towards it and bump into it, I will attack, and it will respond by attacking back. Bink. There you go. You hit the emu more. It was an E, and they called it an emu. You have defeated the emu. And I now have 2 experience points, but I'm still level 1. Okay. And that is how the game works. And as you can see, there's a star on the floor, which denotes gold. And if I walk over the gold, it says you found 57 gold pieces. Your score goes up. And that's the whole game. The other thing you can do is take actions with your inventory. So whatever you have in your inventory, you can use in various fashions to help you succeed and win the game. That's nice. And that's as complicated as it is. And I think I've just described let's say over 50% of the AAA games that have been released in the last 12 months. That's all I do. The only difference between them and this is that they have graphics. Well, this does, in a way. Simplified graphics. And they are probably real-time, not turn-based. And that makes a big difference in how the feel of a game will work, because there's more pressure on you in a non-turn-based game. I mean, like this, I can go and make a cup of coffee and the game's not going to do anything. It's paused. If you're in one of these AAA games in the last 12 months, you go and make a cup of coffee and you will find yourself in like a waiting room, waiting for your next match, or you will find yourself disconnected for being AFK or something. Because it's real time, they don't want people hanging around doing nothing. These AAA games are based around, they want players to play, not players to hang around having a nice time. My cat's just come upstairs. He's not feeling very well. Okay. I'll look at him. It's okay, Pudding. Yes, I'm talking about you. It's okay. You rest up there, love. Bless him. So yeah, we're starting to see the pieces now coming together on the programming side of what makes a game. But that's totally irrelevant. Absolutely 100% irrelevant. Why is that so? Because it doesn't matter. That's not what makes a game. What makes a game is the person that plays it. Now, that means, it's quite funny because I think Seppi was joking the other day, you should have taken psychology. Oh God, did I just flash the screen? Is that me? I think it was. You should have taken psychology. Well, I did. And this is why. Because what makes a game is actually a psychological answer. Oh, they're right. Those two doors meet up. I've never seen that before. I didn't know that functionality was included within this game. It's a psychological answer. There's no programming answer to the question, because there is no answer to the question. So we have to answer our question not with an answer, but with a different question. In other words, the question is wrong. It's not an oxymoron. It's an unanswerable question, rhetorical. There is no answer to it. What makes a game? It's rhetorical. There isn't an answer. There is, however, an answer to what makes a game successful. And that's what game companies who make these AAA games have become good at. What makes a game successful? They can write any game and it will be a success. They have set formulas for what goes into the game. Somebody has an idea of how it should look, or the theme of the game. There may even be an original idea behind the game. But that's all irrelevant. That's not what the game companies are interested in. What they are interested in is money. And this is why it's answerable and it's not a social answer. What makes a game? In computer terms, what makes a game is the amount of success, how much money it can make. How many people will play it. Now, the game I've got in front of me here didn't make any money. But in today's terms, this game is still being made and it's making a lot of money. So its children, the children of this game, are making a fortune. Literally a fortune for a lot of, well, quite a few people. So this game is very, very sellable. It is the type of game which today makes large amounts of money, and I would say over 60% of AAA games today are based on the principles within this simple 1985 game, the original. They may not be turn-based, and they may not say that they're roguelike. They may say, for instance, they're a first-person shooter. Well, that's this game. It's a lot of adventure games. This game. This is an adventure game. This is a combat game. This has everything in it, but so simplistically put together that every other game is within here. There are the other side of the coin, the other 40% of games that get released, which are things like board games on computers. There are other genres of game. I'm trying to think of one that isn't involved with this one. I'm struggling. That's bad news. I never prepare these talks. I should do, I suppose. Oh, where did he come from? Just appeared behind me. A letter K. It's a kestrel. Missed. Oh, I got hit. Look, my hit points went down. Okay, so I'll go towards him again. I hit him. Yay! Oh no, I've been injured. My hit points have gone down. Come on, we've got to beat this kestrel. Yay! We've defeated the Kestrel. Look at my hit points. That's very, very harsh. But hey ho. That's part of the game. And that's what... I'm not saying this is an exciting game, because it's... I don't think excitement, or I don't think any games are exciting, really. Oh, the driving simulations, that's the one that is nothing to do with this. That's a completely different idea. Although the control schemes are still the same, aren't they? Just the graphics are different. It's not exploration and it's not combat. So, right, okay. We'll go with driving games. And then you come to things like Elite, which is still this game. There's all the components of this game in it. I can't think of anything. So driving games. Board games. Well, some board games anyway. Oh well, we'll see. See if I come back to it or not. So we've asked the wrong question. We've decided that much. What makes a game a success is what I nearly titled today's talk about. What makes a game a success is the people that play the game, not the people that make the game. Somewhere there has to be a crossover point where the people that play the game and the people that make the game, there has to be something in the middle that makes people want to play the game. And that's where the game companies, the AAA game companies especially, have got it right. So the game can be absolute dross, but a AAA game company will still mostly, with few exceptions, sell it and make it a success. I think there's 2 exceptions that I know of. One, I can't remember the name of the game, and the second one I can't say because it's probably a meme or something by now. But if anybody who follows games will know which 2 I'm talking about. 2 obvious ones. The feedback from all of this affects a AAA game company on how it will approach selling its next game. So to get the initial success, if you get an initial success and it's a good game, it will become easier for you to make the next game, the quality of which is very variable, remember, and sell it. Either as a sequel or a different game by the same company. Oh, they made a really good game, so this is probably a really good game. And that's how the psychology behind it works. On a simplistic basis. It's like theme parks. Ah, there's a game. Engineer. Cities and theme parks. Building games. World builders. I think the genre is called. I'm not sure. I don't follow these things anymore. Oh, look, we're back up to 5 hit points. You see my hit points coming back. Yeah. There's actually a rest key, the period key, the dot, the full stop. If I press that, it passes. My move is passed. I don't actually do anything for my turn, and the game takes its turn. So You can stand still and do nothing. Gather my thoughts back again. So, what is happening in the game industry is they have a meaningless attribute, or a game company will have a meaningless attribute of reliability, maybe. Accomplishment. Doesn't mean they're going to do anything in the future that's any good. It's just what they have accomplished so far. A resume. Have to be very, very careful with that word, because that is a positive word, not a real. A resume is a list of achievements, not a list of what you've actually done. Resume usually misses out the negatives, shall we say. It's not a true reliable metric, I think they call them nowadays. They use metrics to judge everything. Score this. We will score this game 1 out of 10 type of thing. How do they do that? I mean, these game reviewers, are they graduates of sociology or psychology? Is it an opinion that they give? Is it a real metric that they give? Something that can be proved? So, yeah, and that's where all the problems come in with today's game industry, which I could be very negative about, and I could really have a rant about them, which is pointless, because I think the average person who's a game player isn't stupid. They don't need me to rant. They can make their own minds up. They're intelligent people. So, none of my business. What makes a game successful is what we're on about, though. And what we need to do now is take a step back from that. Do we want to make a quality game that is successful? And by quality, I mean, how can you put it? What you've got in front of you on the screen, this is quality. It might not look great, but it is 100% quality for a game. You can play this game today, you can play this game tomorrow, and you will have a different experience each time. You will find out new things about the game as you play it. Or you look them up online and they call them spoilers. Well, that's because they are. They spoil the game, really. I mean, I've done a lot of research into this game, but I've still not looked at the spoilers. I've looked at the code rather than the spoilers. So I know the mechanics within the game, how it works. Doesn't spoil the game for me, because I can never remember what they are. I've never seen this kind of layout before. I'm not sure which way to go now. All right, we'll take our first break at this point, because we've now, I think, got to the end of part 1. We've discussed the title. In part 2, I would like to go more into computer games and ask the question again. Computer games, what makes a game? So I think that's a good place to take a break. so that people, if they watch this, will know where, like, each chapter or each part of this talk starts and finishes. So let me put something on screen that will mark it. There we go. I'll go and make a cup of coffee. We'll take 3 minutes out. We'll mark this section of the video so that it can be referred back to later. Go make yourselves a drink, settle in and enjoy. Okay, I'm back. Still on the break though. Let's see, what have I run out of here? I've run out of stuff in front of me, so let me just do refills and things. So we're on our break, so enjoy the cup of coffee. I think we should have a cup of coffee. Alright, let's have a look at this. Oh, right, this is what I did. I wonder why I did this. Sometimes I have no idea why I've done something. Getting old is not a good thing to do. Well, it is actually. I'll tell you a little secret. The older I've got, the more I've enjoyed my life. And now I just purely enjoy everything I do, so it's ace. I'm blessed. I have a blessed life. Might not be everybody's cup of tea. I absolutely adore it. I wouldn't do what I'm doing if I didn't. Where's the mousey thingy? Right, part two. Main. No, capture card, isn't it? Yeah, capture card. There we go. Part 2. I'm going to do this from a science and technology point of view, obviously, because that's what channel I'm on Twitch. So we're going to have a look at computer games today. And part 2 is... what makes a computer game? So I've now progressed through from 1. We're not going back onto that, I hope. Unless I get sidetracked, which is normal. What makes a computer game? Well, the simple answer is a program. Well, that's not quite true. Because you also have to answer the question, why has a computer game been made? And there's always a reason. Even if it's as simple as, oh, I made this computer game because I was inspired by a game that I've already seen. That's how the roguelike genre came about and became the main basis for computer games today. People liked what they saw. They found the game interesting and at times intense, which this game actually is, which is weird. But it's intense because it's psychological. I don't think it was intended to be that. It was intended to be a test for mainframes. So this game was never intended for a player base. And yet it's got the biggest player base in the world today. So, what makes a game? Some kind of intention leads to a program, and then that will lead to a game. The program is not the game. The game is, a computer game is its packaging, its intention, its advertising, and its revenue. I think that's the simplest I can put it. I'm not being opinionated today, you might have realised so far. I'm trying not to give an opinion, I just want to give the facts. So I think that's the simplest definition I can give what makes a computer game. And I do want to focus down later on more into the programming side, obviously, because that's what I'm involved in at the moment, and I'm hoping that people are interested in programming games. Not being game programmers, but programming games. Now, on the hobbyist side, the intentions are usually because you think it's a good idea. And if you say that in a business sense, oh, I think it was a good idea at the time. That's not how business works. Business doesn't work on it's a good idea at the time. Business works on good planning. So we'll have to either stay on the business side, or we have to detach ourselves from that and just focus ourselves into the program and detach ourselves from the intention as well, and just single out and look at the program. We can't, well, if I was to talk about all of it, it would take a week. I'd be streaming for a week. I'd need food supplies for that. So what makes a computer game? A lot of people reply, well, a program, of course. Well, that would be wrong, obviously. I've just said what a computer game really is. It's a lot of factors, and sometimes those factors can be very subjective. Sometimes they are real factors and they really can be measured. I think everything to do with business can be measured in some way or another. So, what makes a computer game a program? How shall we show that today? Oh, I can't use that mouse. Okay. Oh, I can't do it that way either. What have I done wrong here? F11, that was it. Oh, wrong keyboard. There we go. Let's see if I can work a computer. I do that. This is very awkward to do, actually. That and that. And that. What makes a computer game? And there is a very, very simple answer. And the answer is staring us in the face. The look, the feel, how the game plays, the kind of impression that you want to give to the player. Remember, you're presenting something when you're designing this. You're designing a presentation. A game can be classified as a presentation, an interactive presentation. It's a good definition of this focal point of the game. And that's very important. Because what it means is, and this is where game programming goes wrong, and I mean seriously wrong. I mean so badly wrong that a game program may never see the light of day because of it. It's taking data stored in a computer, placing or representing that data on screen in some interesting way in which the person using that program, the player, interacts and finds that interaction interesting, intense. I'm not going to use exciting because I can't think of an exciting computer game. I mean, the idea of horror games coming out, I wouldn't call those exciting, but they can be very intense. So I would say intensity. How intense or what kind of feelings does it generate within the player? And you are looking, a game is looking usually for intense reactions from the player. Combat is used in this game and the data for the combat system represented on the screen is simply represented as information displayed as a message. Yet it works. And it works very clearly because it's a turn-based game. It makes a player stop and read the message. And by doing that one simple thing, they made the game immensely popular by accident. So what makes a game? Presentation of data is the answer. And I came to a full stop yesterday because what I have in front of me is the core data for the game. I put it into 3 very, very simple sentences for programming wise. In English, obviously, I program in English. I don't know any other language to program in. And I stopped. And I realised I'd written 3 lines that I couldn't answer. I'm not going to say that every game is different in this part of what is a computer game, because they aren't. They will represent their data in certain ways, 3D models, for instance, or the model data. How the game looks, is it fantasy, science fiction, fiction, real-time, historical? All of that is representing just data that's stored someplace within the computer. How do you answer the question of, on the programming side, how should the program store that data, which is what I've asked here. I've got the wrong keyboard in front of me now, haven't I? 1 second. Oh, that's tangled. That's bad. Okay, keyboard malfunctioning. So in those 3 sentences there, I have asked the stupid questions. The stupid question, how do we store this data? I very, very naively and stupidly asked that question indirectly in 3 lines of English. The clue is in the first 2 lines, but there is, in computer terms, only one way you can store data. And the answer equals a block of memory containing numbers. So now we're actually coming to the factual part of that. Containing numbers. Because that's the only way you can store memory. And you'll hear a lot of talk about databases, about key trees, tokens, classes. It should never store data. Oh no, sorry. classes are not... Yeah, okay. I've jumped a massive step there, sorry. So we're on a block of memory, aren't we? Let's retreat back to this block of memory. Now, that makes it very easy for me to answer this cycle through treasure types. Roll the dice, cycle through treasure types, look it up in a block of memory, and there's your data. So what I had written was very, very simple once I'd thought about it. But the problem that hit me yesterday was the overthinking because of the concepts behind what I had written. And I think that's going to be our next chapter. So a block of memory in a computer is addressable. So hopefully this is going to work. Let's pop you to there. Get rid of my phone. It's not needed. Move you over to there. And I think I've got a pen here. Okay. All right, is this working? Oh, it is. That's good. Here we go. Oh, that's okay, that'll do. Right, so data. Is what this part of the talk is really about. What makes a computer game? And it boils down to the subject of this point here now, and it's data. This is represented and has to be represented within a computer at some point, because of the way computers are made these days, very badly. As a block of memory. So all data at some point goes through a block of memory. So a block of memory. Oh God, that's got a button on it. Okay, let's try that again. It's a block of memory. Containing numbers. Okay. So now we know what this data is. So you will have your memory address. Okay. You will have your data. And it will look like can't use that, can I? That's not going to work. Oh god, this isn't a Dubry thingy. Never mind. Scribble it out then. What was he using? That one. Yeah. So the memory address is oh, we'll use a star, can't we? That's an 8-bit. Eight-bit memory address. The data will go. So let's see. That would be 1, 2, 3, 4. I've done that wrong now. Oh god, that's hard to do. The thing disappears when. Oh, well done, Microsoft. Sorry. They can't even get this right. Oh, whoever made it. 0, 1, 2, 3, and then it goes 4, 5, 6, and 7. Okay. So your data is held in memory like this on an 8-bit machine, not on our 64-bit machine. It gets a little bit longer on what you can put here. Each of these data points can hold 1 bit. And then you have to go into what's a bit, what's a byte, what makes a word, and all that kind of stuff, which I'm not going to teach. It's not. I'm not here to teach people. I'll bring that up here so I can place the pen down. Got a pen holder. Got dust in. Lovely. Bring this microphone back a bit. So that is the data. And we don't have a choice about this. That's the point. This is not a subjective viewpoint on how we are going to manage the data in my program. This is actually a reality check. So in reality, this is exactly what happens. Now, we can have various representations in the program of memory, depending on the language. That's a better way of putting it. So we now have to, once we've realized that this is all it is, and it is this simple, that's the whole point of this talk. What makes a computer game is the data and the representation of that data to the person that plays the game, and how that data is processed, obviously. That's the computer program. The computer program processes the data, and that's what a computer program does. That's all a computer program does. Just processes data that it's been given, or even displaying data is processing it. You have to process data to be able to display it in a meaningful way. We'll talk about that in a bit. And all languages, or all computer languages that you can use today and have ever been invented, represent this format of memory address and data in different ways. And some are very, very useful. Some aren't, and can be cumbersome and difficult to use. Now, this means that there is no such thing as a database. I hope the penny's starting to drop with anybody that's watching this. You can't have a database because that database is not held in memory. A database is a storage of data outside of the program in a format. It's got nothing to do with the program. It's got nothing to do with the computer game. A database means that you are storing your data elsewhere or in some format. You could write a database into your program. I can't really see the point of that. That would be very, very cumbersome, and your program would become very, very large. If you have a look at how big database programs are, you'd understand, I guess. Can I switch to a database program? No, I can't. But you will find there are database programs out there, and quite a few popular ones. I'm not going to name any because I'm not here to advertise them. Databases are databases. They take data and they store them in a fashion which make it easier for a human being to relate to and use large amounts of data and operate on large amounts of data in what is considered in human terms very quickly. What is termed in a computer game terms, unfortunately, is very slowly. There is a perspective difference going on there. So a lot of hobbyist programmers would probably tend to use a database of some kind. No, not like. I'm not saying the word. And to them, they would use it because it's a quick method of storage by human standards for large amounts of data. It's easy to manage, and yeah, there you go. That's why databases are commonly associated with programming games. But in game terms, a database is so slow compared to a memory address access for data that it would cause massive problems to do that. And the logistics of getting around that and using that kind of thing is no small feat of programming, and would require something a little special going on, I think, to make it successful in its implementation. So that's databases. The other method of storage is... No, there are other methods of storage, which I can't go into. I don't know if they're actually copyrighted. Oops. Let's just say databases are not the be-all and end-all of data storage on devices. There are other ways to store data on devices which gives quicker access and more direct access, and can speed up the idea of having external data available to your program. Now, what I've said so far is that it's a block of memory containing numbers, and that's exactly true. That is the truth of the matter. And that's what you've got to keep in mind. What would happen in 1985 when this kind of program came out called Rogue? What would have happened there is the data would have been limited to the memory of the machine that it was programmed to be on. In that case, it was a mainframe. Memory really wasn't too much of a concern. So everything is in the program. All the data is within the program. And at the beginning of the program, it's there in memory, ready for access. Because when a program starts up, it's loaded up into memory so that it can be processed by the CPU, the computer, the central processing unit. Because it's being loaded up into memory, it becomes very easy as a programmer then to have a block of memory with data in that is loaded up with the program or internal to the program. So we have the internal, and internally it has to be stored in this fashion with a memory address and a block of data. Memory address, block of data, memory address, block, on and on and on and on for however much data you want. So I should really go dot 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 for however much data you want. Lots and lots of data. I mean, I've got a 0.5 meg of data being loaded up onto the graphics card just for the graphics. That gives you an idea of how much data I'm using. For the 3D modeling, I've done the 3D modeling purposefully that way, so that I wasn't restricting myself to what kind of data I was using, and to make my programming easier. But all of that is done at the start in an initialization. So all of the data so far is internal. And quite a lot of the data that I'm using can be generated. Oh, wait a minute. But I've just said it's a block of memory containing numbers. Well, it is. But what I've done is something called, well, it's not generating on the fly. It's internal and can be, and this is very important now, extrapolated. And this, I don't even think this is taught today in programming courses. Data can be stored, but data can be created. So IE created. Created, generated, Yeah. Put that one. Oh, it's done it again. Right click. Okay, is that what I did? Generated. Do that because it's a felt tip and it looks nice. So was my original statement true? Data is just a block of memory containing numbers. Yes, it is. As the program runs, from that block of data, it will generate new data as required, either for displaying to the user. In other words, numbers are converted into characters or ASCII and then displayed on the screen. That's a simple. That's probably the most simplest form of conversion or programming conversion that you can do, is take your number that is stored in memory and convert it to a letter and then display it on screen so that it can be used to transfer information to the player. So that's how data is used. So I think we need to know about how data is used as well, don't we? Interesting. So data is processed. So processed. For use in the game. So for use. Yeah, I'll do. Have I scribbled enough now? Yeah, I think I have. How are we doing on time? Oh, this section's not too long. So I think I've now answered what makes a computer game. It's numbers. So answer is there. I can't underline that enough, because that's exactly what makes a computer game. So that's the title of this section, what makes a computer game. And that is the factual answer, numbers. You might say, but what about all the rest of the stuff that it does, like processing or generating or extrapolating or creating? That doesn't make a computer game. A computer game is made up of a block of memory containing numbers. That's all it is. All the rest of it, well, those are just systems, which can be generic systems, different equations, doing different things, different mathematics, doing different things, like the it does beg the question: do you need to be a mathematician to make a game, a computer game? I'm tempted to say yes, but that would be subjective. The answer is no. The reality of it is no. You do not. The reason being is that nowadays we have computer languages that don't just hide the fact that you're dealing with a block of memory containing numbers. They don't just hide the fact, but they encourage you to program in a non-mathematical way. The word that they've come up with for this here, this line here, memory address data processed for use, they've come up with a new word for that, and that word is algorithm. I'm stuck now because I can't spell it. I'm gonna look at that. Sorry. ITHM. Okay, thank you. So I was right the first time. Okay. Yeah, great. Did that just close the program? That was interesting. At least you see what problems I come up with when I use Windows. There you go. Algorithm. Doesn't look right to me. That's the word they've come up with. So now in high-level languages, instead of doing mathematics, you implement algorithms on what we're going to talk about next, which is containers, data containers. I hope by now that you've realized that due to the many options that I've just been through and the length of time it's taken me just to put my thoughts across in a factual way, that you realize now what happened to me yesterday afternoon when I saw those three lines. And I couldn't carry on programming. Because at the basic level, the variation is huge, but the actuality is one thing. Oh, right. It does that. Why is it doing that? Is this... What? All right, Windows, do what you want. I don't care. So I knew that the answer was I need a memory address full. I need a set of memory addresses full of numbers. I knew that. But what completely stopped me dead in me tracks was everything else. All the questions around how does that data get there, which is the next section of this talk, I suppose. So I hope that I have expressed this in a plain way, that what makes a computer game is numbers, which is a set of memory addresses with data in, which we then process for use. Whatever you'd want to do with it there, I don't care. But that is the answer. And that you have to... It's really got to sink in that there is only one answer. There are not multiple answers. There are not choices to make here. The answer is... Oh, no, don't do that one. The answer is a block of memory containing numbers. And that's the only answer that you can have. So we want to look into this a bit further, because that seems a little simple as an answer to what is a computer game, a block of memory containing numbers, which is the truth, actually. So what's all this lot here? Well, you can see it here, generator. You can see it here, generator, generated. Okay. God, it's flashing. Here we go. Here we are. So this is a fantastic example of placing numbers into memory. All right. So what we do is we read a file. It's in orange, which means it's a command. We read a file. We put the data that we create into storage, which is the next part of this. Okay, storage, storage. Okay. And the data itself is stored in memory, in this case on the graphics card. So the data is read in and stored on that graphics card in a block of memory as a block of numbers. Size of unsigned int times vertices indices dot size. That's a block of memory there dot size. So we're actually having to tell our graphics card how big in bytes this block of data is. And then we tell it where the start address is in the computer's memory, and that then transfers that block of memory over to the graphics card into too simplistic, the block of memory that you have reserved here, or told it to create here, should I say. That's an actual request for creation. And that's what it does. So this is all done. The model loader is done where? Create. Oh, it's gone again. Basket case. Thank you. Create. Okay, we do have extrapolated data within this program as well. I'm just trying to remember where it was now. I'm going to close this because it's really bothering me. So I think we're finished with that. Okay. So at this point, I think part 2 is complete. I think I hope I've driven that home. That what we're dealing with here, why I'm now going to describe why I had a massive problem with it all. So yeah, we're here, aren't we, in the program? So let's take a break, have a cup of coffee, chill out and relax. That took longer than expected. I apologise for the length of time I spent and dwelled on that one idea. I really want people to realise the truth about what programming or programming a game is about. So here we go. Take a break. Coffee. All right, I'm back. All right, so we need to look at data storage, don't we? Really, as the next part. So that's going to be, I think, the title of part 3. Actually, I should really be doing this, shouldn't I? So, part 3, data storage. Okay. And the reason I'm doing it like this as a talk is mainly because I wanted to show why I'm going to do what I'm going to do here, I suppose. How did I come to my final decision on what to do? What it means, really, in terms of the game. So, put you back on main. I'll leave it on here for a minute. So part 3, data storage. Welcome to part 3. Hopefully by putting those be right backs up, you can navigate through. And it's already 2 minutes past 3. So this might be the end of today's talk as well. My God, part 3. Data storage. How can I explain data storage? Right, so we need a block of memory, don't we? Okay. Let's see if we can get this to work again. And part 3, we're on. So let's note that up here. Right. Data storage. This determines how... Well, actually, no. This is hard to put into words for me. Because there are an infinite amount of ways in reality on how you can do data storage. It just depends on how inventive you want to be. There are ways of storing data which will compress data into very, very small sizes. So we have data containers. This is from the programmer's point of view. Okay, and external. Those are the two ways. Now, external data still has to... Yeah, it's not a plus sign, is it? Let's be honest. Bad way of doing it. Okay, let's hopefully keep this felt tip pen working. So there's external data. It still has to go through a data container. And that goes to the processor. Okay. So I want to draw this time. So that's the basics of what we're talking about now. Data storage, data containers. The external data still has to go through data containers in some form or other. So what kind of data containers can we have? All right, so let's make a line here. Containers. Depends on the computer language that you are using. So containers could be, well, I would say that most computer languages have a direct access. Which is how it used to be done, especially in the 80s. Brings me back to those old days of peek and poke on the PET. That was always good fun. And the Commodore 64. So there's direct memory access. There's variables. I would say most language has variables and arrays. And yeah, that's it. any other thing that you see is usually a structure of some kind of combination of those three. Structure or a class or something like that, of those three items. So it doesn't matter how the language syntax looks, that's what you've got. That's it. The whole thing on one screen. Wow. I managed to get it on one screen. I did well, Muppet. Thank you. So there we go. Data storage in a nutshell. But it's not quite that simple. As I said when I was trying to work out how to express it on the screen, I managed to get it on one screen. Wow. There are an infinite number of ways that you can do this. Just because a language gives you variables and arrays doesn't mean you have to store your data that way. You can invent your own way. That's how databases came about. Somebody invented the database. You can have text files full of data. That's how I store all the model data. I don't know if I can read it as a text file in this stupid system. Ah, yeah, you can. See, data. That can be read in. All those MTL files could be deleted, really. Oh well. So, there we go. We have some kind of reference to what these things are. Oh, those letters mean something. They're actually titles, or headers, or heading, or names. The name of the data, or type of data. So I would say type. Name type. Yeah. Something like that. Which really makes that an array. But hey ho. Data storage itself is, oh my god, what is going on here today? That wasn't me. I didn't even touch the computer. For some reason, this program likes to close itself randomly. Does that mean it's a good piece of software? No, it means it hasn't been tested under this situation before. Or by anybody. I'll give them some... No, I'm not going to give them some feedback. They can do their own goddamn jobs properly. Oh, that's another thing. No, I'm not going to say that today. Can't. I'm having a day. I'm having a prohibition day of opinions. I'm having a factual day. So why do I say this can be done in an infinite way and you can become very inventive about it? Now, I learnt all about this at a very early age, unfortunately, before I even learnt in-depth programming, shall we say, like assembly language. The reason being is that at that point in my life, I was a bit of a hacker, shall we say. So data is also your program is represented as data on some kind of material or thing where it gets loaded into the memory from. Nowadays, the data for this sketchbook program is actually in memory and in memory on a solid state memory device. So duplication of effort is going on there. Anyway. When will solid state drives take over from the memory chip? That's the big when. When it comes to a program, this is the biggest decision in your programming that you will ever make. How you decide to store data programmatically will affect what you can do with your program and how you can interpret your data within that program. But at the end of the day, it shouldn't. And that's what I'm trying to get at now. At the end of the day, in a game, any data that you want to use has to be accessible instantly at any time. And that's your bottom line. Because in a game, it is usually fast moving, which I'm not programming a fast moving game at the moment, but hey ho, can be dependent upon frame rates. And unfortunately, it's something that has been used to sell games. But frame rate is a metric that is now an accepted norm by the public, not by the game industry, not by programmers, but the public, as to the competency within which the program has been written. Or, in other words, the standards of a program are inferred by its frame rate. Its frame rate is dictated by how fast you can get your data from memory to the screen. And removing any delays, obviously. And that dictates how you store the data. So I want fast, movable data. And so I get to the next part of my answer. Now, variables ain't gonna hack it because that's only for low volume use. So you've got direct memory access, which would be interesting and is probably the correct answer. You've got variables, which are low usage, or structures, or whatever, storage containers, usually used as in-betweeners. Glue, the stuff that glues everything else together. And then there's arrays, which are just a storage container developed so that you can have a way of doing direct memory access without having to write some nasty programming stuff. So Arrays is probably what we're going to have. So that is now going to equal arrays. Because arrays is the easiest way to program direct access of memory in a way, but it isn't. No, it's the easiest way to program indirect access of memory, because arrays are indirect. I've got to be honest about it. Direct access takes a lot more to do. Indeed. So we're at the start point now of our data. And I was going to continue this into traveling through the system and watching how the data is transformed into what the user reacts or interacts with. I was going to do it all the way through, but I think this is going to be the last section, unfortunately, today. So at the end of the day, how do we store this data? A block of memory containing numbers which equals arrays. That's the answer that I couldn't come up with yesterday on the fly, because I'd forgotten the truth behind it all. This is not the most efficient solution. Most efficient solution is that one there. And that one there was used in the original game. The original game used direct memory access. There you go. That's what Windows thinks of direct memory access. So I'll go with arrays. I'm going to leave that switched off now. Don't like that flash. So really, what I've got to talk about now is what is an array. An array is a block of memory. Simple as. Which you can access. So an array, this is where I really want to be drawing. 1 second. Thank you. Yielding. All right. Okay, that's okay there. Let's go on to that one. And we can't do it, can we? We can if I push that button there. Windows is Windows, after all. So, an array. Right. What you would specify when you use an array is a number. So type what the programming language will do is then take a block of memory of size. So it will take number. Oh God, I got that wrong. So it's number times size of type. equals block of memory in bytes. Now, if you don't know what a byte is, don't worry about it. If you want to ask about what a byte is and all the kind of things like this, I would think I would have to prepare a better presentation for that kind of thing, because it's so far back in my memory now that even I would struggle to bring it to the surface. I'm getting way too old for this kind of thing. So there and that will give us address, zero to number. I've done it again. And the data in bytes. And that is how it works, folks. And that's all numbers, and that's all numbers. So there's your block of data of numbers. And that's the simplest way we can do that. Okay, that's the simplest format of a block of data in most, and I do say in most languages, because it's not always correct. That didn't look very good, but never mind. All right, just switch that back to that. That down. Drink me coffee, I think, now. Finish this. So that gives me my final result. So that's how I'm going to program it, is the answer. What I should have realized yesterday is that this is the only way it should be done. Well, it really should be done by direct access, because I wanted to emulate the original game. But I'm not going to do that, because that involves quite a bit of extra programming, which is just not needed in the language that I'm using. The language that I'm using has arrays and is very simple about them. And we've already been using them. These are all arrays here. Okay, that's just a number, 80. Breadth is just a number, 40. And that's the values that I've put in it. So I've taken 80 by 40 memory addresses. That's 8 fours are 32, so 3,200. 3,200 memory addresses, and I've placed the word, well, the number false in there, which is it 1 or 0 on this system. It's either 1 or 0. For some reason, it doesn't tell me. I've never understood why. It'll tell me what that is, but it won't tell me what that is. Interesting, all the blue bits. See, it comes up with something for that, but it never comes up with anything for the language. Those are all the blue bits are part of the language. Everything else isn't. Everything else is what I've just made up. There's not many blue bits knocking around, is there? That's the language. Everything else is stuff. Variables are in bright green. Those are the in-betweeny data types. As you can see, I'm creating data here. Trying to think. Yeah, I'd have white and grey. So that's a variable. And grey, that's a memory address. Yellow is a label. Yeah, it's just a label, that. It's a variable. Orange is a function, or the name of a function, which is an algorithm. As you can see here, that's an algorithm. That's what algorithm means, for some reason. No idea. I call it a couple of for loops. They call it an algorithm. Fine. Function or an algorithm. And that is a class or struct. Two different names, same thing, just different ways of the information being stored, either as public or private. In other words, private to itself or public, so it can be accessed externally. And that's it, really. That's how I'm going to move forwards with this piece of data, or this mass of data that I've got. Is I'm going to have an absolutely huge block of memory containing everything. It might be sectioned up into smaller bits so I can manage it properly within the program. But at the end of the day, that's what it is. Just like all of these are a huge block of memory on the graphics card as they are loaded in this case, numerically. Anything that isn't a number isn't loaded at the moment. I've got to convert those into numbers yet. I might do that after this. So, that is how I have come toward the answer. Now, the last bit is ownership. On a programmer's problems, it's ownership. So, ownership of the data. In other words, which file to store the data in. That's all that means in English. That's not a hyphen, that's an equals. So that's my last part, which is what I'm deciding at the moment. I know how I'm going to store it. I know what I'm going to store. I've got all the data already typed in. It's just how it's going to be stored and where. In the original development of this game, I'll show you. No harm in showing people why I've come to this decision and why I've stopped all of a sudden and taken a day to explain myself. Sandrogue. Just open it with code, that'll do. I came across a problem. And it instantly became, well, it's not a problem. I came across a solution that I can't use. and that's it there. Here's all the data. It's already here. As you can see. Problem is, it's in a file called GURPS, which I can't use. I've placed it in the rules set, which is a good place to put it actually, within the rules. Now, I don't have a rule set yet for Amber Skies. And at this point, I have to decide, am I going to go down that route? At the moment, I've kept away from designing the rules by using Game World. Okay? There's no actual rules in here. There's nothing here that affects the state of the game. This is all data management. The monster manual. Data management. That's all it is. Look, 2 arrays. Wandering monsters and resident monsters. Arrays full of data, which starts off as unused. Or -1. See, it tells me on that one that it's -1. It's 80 by 40 integers of -1. And an integer on this system is 64 bytes. So it's got 3,200 bytes, memory addresses of 64 bytes worth of unused. Yeah, great. Bit wasteful, actually, but it works. It works okay. It works very well for the amount of, because this is actually a large amount of data that I am creating from nothing, really, from nowhere. But as you can see, it's just add, reset, and check. So it's just data handling. So we can reset these two memory blocks. We can add things into those 2 memory blocks, and we can look at what those memory blocks contain. That's the truth of what I've programmed there. That's the system that it is. But nowhere in here is the system that uses it. And this is why I stopped, because I realized what I'd done. What I had done accidentally is I've modularized things. So these are all modules. That monster manual can be taken out and another one could be placed in with different values, but it would still do the same things. The same, 4 actions, or however many actions you wanted to do, should I say. It would be able to reset the memory blocks, it would be able to add to the memory blocks, and it would be able to check or look at those memory blocks to see what value was in there. That's the design that I'm using for a lot of this stuff, actually. But the game world especially. The ECS system is a completely different way of handling data, in which you take blocks of predefined data that's not arrays, because it's mixtures of different data types. You can only make an array of one data type. You can't specify, oh, I want this data type on this line, I want this data type on the next line. It's all got to be the same kind of data type. Whereas these components are storage of data structures using variables. So in-betweeners, but tying down the variable to do a specific job and hold a specific piece of data for the game. And that can be shown in common under the structures for ECS. So we have, not there, here we go, components. There you go, component model position, component model position. Component text 3D, component text 3D. As you can see, they are varying types of data. And that's why these are useful. These are very useful. Now, I could go down that route, but then I would have one of these blocks or structs for each type of item that I place into the game. And I realized that that is not what I want to do. I don't want to go down that route. I want to go down the other route of using an array of a single type. Okay. So a block of memory containing numbers. Numbers is one type. A number is a number. You can put any type on that. You can put integer, floating point, unsigned integer, character, char, star. No, you can't put char star. You can put char. Any blue one. Any standard type without a star on it, obviously, or any kind of stupid notation next to it. So it does restrict me to what I can use, but that's fine. I don't need to really bother about that. I just want a block of memory containing numbers, what they're actually called within the language. I don't care. I don't care what type they are. They can be any type I want. So I think that that's the development of this part of, or I should say that's the decision making that I had to go down or through to get to the answer that I have got in front of me now, which is that the only thing that I have to answer now is that last line, the ownership. And that will be tomorrow when I start the programming of, I haven't even really given it a name yet. I've called it treasure there. Maybe we should have called it that. See, if I call it something like that, it's going to go into the game world. Or do I create a new folder for rules? And then that makes it more interesting. And I'll tell you why I make the decision tomorrow. How's about that for a cliffhanger? So that's it. Any questions? I'm gonna stop at this point because if I continue on to the next part, it's just going to get way too long. Way too long. And we're already coming up towards 4 o'clock. So I want to stop at this point. I'd like anybody who's watched this, hopefully, not necessarily to have learnt something, but to be reminded of how to program. A lot of people say, how do you know, what's the best? I want to learn programming. then they should watch this video or this stream or whatever you want to call it. Okay, so I'm done. And that's now gone weird. Oh, God. Because I'm using that stupid thing. Okay, whatever. All right. So thank you very much for your time. And if you've made it this far, your patience. This video is designed to raise questions within the community that wants to watch this kind of video. And hopefully some realizations and things to think about. So take care, and I wish you the best of luck in your endeavours. And oh, there it is, this one here. Have fun.